Page 3 of compound interest. Number 6, Mr. Lin deposits 10,000 Chinese yuan with Bank A that offers a 8% interest per annum per year, compounded half yearly. Okay, so Bank A is 8% interest per annum, compounded half yearly. So K is equal to 2. Bank B has 8.2% compounded yearly, so K equals 1. Calculate who will earn the most interest after 2 years. So Mr. Lin does Bank A, Mr. Lee does Bank B. They both start with a present value of 10,000. Okay, or on the calculator you would put maybe negative 10,000. And then we're going to see what they get after 2 years. So n is equal to 2 in both cases, right? Okay, so let's compare these two. So first we're going to do okay, we're going to go up to n and we're going to put 2 because it's 2 years. We're going to put 8 for Mr. Lin in Bank A. Present value, we're going to put negative 10,000. The reason why we put negative 10,000 is because the money is leaving Mr. Lin's wallet, for example. Or you could put positive 10,000, then you're going to get a future value of negative. So the future value, we don't know. That's what we want to find. Payments per year we don't use. Compounds per year, we use the value for K, so 2. Okay. So I think everything's okay. Now we go to future value and we do alpha enter. So the answer is 11,698, 11,698.59. And for financial problems, we always are going to find the cents. Okay, so that's why we go to 2 decimal places here. All right, now let's redo it. This time we're going to use the interest of 8.2% for Bank B. And Mr. Lee, 8.2. And then we're going to go down to C divided by Y. We're going to put 1. Okay, and then we go to FV, and then we do alpha enter. Okay, and then once you do that, you are going to get the new future value for Mr. Lee, which might be more, it might be less. It's kind of hard to tell because it's a higher interest rate, but less compounding per year. So I'll leave that for you to do. Number 7, a bank is offering a rate of 6% per year, compounded monthly. Okay, so we'll write that down. I equals 6%. Compounded monthly, K would be equal to 12 compoundings per year. So K is the same thing as C divided by Y. Mrs. Alcott invests 1,000 GBP in this bank. Calculate the amount of money she has in the account after 5 years. So N is equal to 5, and present value is equal to 1,000. Okay, so we'll calculate that. And remember, on a test, you would want to write this out with the formula, because if you do get anything wrong, then you will get partial credit. So you would put 6% divided by 100 divided by 12, 12 times 5, okay? And then you can go to your calculator and you're going to put all that in. Now present value is 1,000, right? So you would put 1,000 here. Now on the calculator, remember you are going to put negative 1,000 instead of 1,000. So N is 5. The interest rate is 6%. The present value is 1,000. The future value, we don't know yet. Compounding per year is 12. And then future value is alpha, enter. 1,348.85. Since we put a negative present value, the future value is given to us as a positive number. Okay, now Mr. Bunt, that was Mrs. Alcott. Now Mr. Bunt invests X GBP in this bank, and the amount of money in his account after 5 years is 4,000 GBP. So we don't know what Mr. Bunt started with. We just know that after 5 years he had 4,000 GBP. So the inside is the same because it's the same bank with the same interest rate. Okay, what we don't know is what the present value was, X. How do we find that? Well, the calculator can find any one of these as an unknown. So like if we put that the future value is 4,000 and the rest we leave the same except for, let's see, also for 5 years, right? So we can leave n equals 5 also. We don't know the present value because it says that he invested X. We don't know how much X is. So to find out X, we do alpha, enter, and we get that his X was 29.6549. Okay. And it said correct to the nearest pound, so we could put 29.65. Okay. All right. Part C. Calculate the number of years it would take for Mrs. Alcott's money to double. Okay, so in this case, we're going back to the original problem. So instead of a future value of 1,348, now we have a future value of 2,000. Right? So we start out with 1,000. How long does it take to get to double, which is 2,000? Now the thing is with these compound interest problems, once you find out that you're supposed to double the money, it doesn't matter if you put 2,000, 1,000 here, or if you put 200, 100, or if you put 2 and 1. You will see that whatever numbers you put here, as long as the ratio is 2 to 1, that you're always going to get the same length of time. Okay, so in this case, we don't know, let's see, it's going to be 12. We don't know what the time is, or the number of years. We'll put n because we usually use number of years. N, okay. So we're going to fill in the numbers here. So 5, the n we don't know. The I is the same as before, negative 6, or 6. The present value is going to be 1,000. So we could put negative 1,000, for example. Delete the rest. And then the future value is going to be 2,000 because we want to make it double. And then the c divided by y is 12. And then we want to find out what n is going to be. So we do alpha, enter. And it gives us 11.59 number of years. So c would be 11.59 years. Okay. Now, is this the last problem? Yeah, this is the last problem. Kelly has 8,000 euros to invest. She invests A euros in Bank A, which offers an interest rate of 6% compounded yearly. The remainder of money she invests in Bank B, which offers an interest rate of 5% compounded annually. She received total interest of 430 euros at the end of the year. Write an equation to represent this information. Okay, this is kind of a complex problem. So Kelly has 8,000 euros. She invests A in Bank A, and the remainder goes to Bank B. So for the remainder would be like 8,000 minus A, right? So this would be the present value of Bank A would be A, and then the present value of the other bank would be 8,000 minus A. Okay, what else do we know? And Bank A has an interest rate of 6%, compounded yearly. Compounded yearly is K equals 1. The remainder of the money goes to Bank B, which has an interest rate of 5%. And then, which is also compounded annually. She received a total interest of 430 euros at the end of the year. Okay, so that means that if I would write everything together, I would say, okay, so 8,000, I'm sorry, that would be A, and I'm going to use the future value, present value equation. So I'm going to have A times 1 plus 6% divided by 100, and K is 1, so I just put that there. And then it's at the end of how many years? At the end of the year. So n equals 1, K is equal to 1 also, okay? And then I'm going to add the other part of the money, and the present value of the other part of the money is 8,000 minus A. And then it will be multiplied times 1 plus, and the interest rate is 5 divided by 100. K is equal to 1 again. Okay? So since K equals 1, I can just erase these. Alright? So I have this formula, and this is going to be equal to the interest made in 1 year. Now, could I just put 430 here? Is that the interest? Not quite, because when you use these formulas, it gives you the whole future value, which includes both how much you started with, the present value, plus the interest. So actually what this gives you is the total amount, 8,000, plus 430. Okay? So the formula looks like this. It has, on the left side, it's got the two future value equations, and on the right side, it's got 8,000 plus 430. Okay, so that's part A. Now B, find the amount of money that Kelly invested in each bank. Okay, so now this is a little trickier, right? We need to simplify these. So this is 1 plus 6 over 100 is 1.06. And then I have 8,000 minus A times, and this is 1 plus 5 over 100 is equal to 1 plus 1.05. Okay, and I think I said 1 plus 6 over 1,000, but it's 6 over 100, so it's 1.06, right? Okay. And that's equal to 8430. Okay. So now the equation is a little bit simpler. Now to figure out what A is, because that's the only unknown, we just need to combine like terms. We'll rearrange everything a little bit, so we'll have 8,000 times 1.05 minus 1.05a is equal to 8430. And then we're going to multiply this out, and it'll be 8,000 times 1.05. That's, let's see, 8,000 times 1.05, 8,400. Okay, and so we subtract 8,400 from both sides, and that'll give us 30 on the right side. This will be 0. And 1.06a minus 1.05a is just 0.01a. So now we have 0.01a equals 30. Divide both sides by 0.01. And then you have a equals 30 divided by 0.01. Just to make sure we don't make any mistakes, we'll do that with the calculator. 3,000. So the answer is that he put 3,000 in Bank A, and then the remainder of 5,000 was put into Bank B. Bank A, 3,000. Bank B, 8,000 minus 3,000, which is 5,000.